Hello everyone, welcome back to our YouTube channel Coding School. Whether you are beginner or an experienced developer, you are in the right place. In this channel, we are making educational videos regarding coding concepts with proper example and its explanation. This is third video on DSA. Till now in last two videos, we studied what is data and information, what is data structures and classification of data structures, in which we studied all three categories of data structures. If you want to see previous two videos, link is given in the description. You can check it out. So let's start with the today's video, and if you understand the concept, please give like to the video, subscribe to our YouTube channel and turn on notification bell so that you never miss an update. Today we are going to study concept of data types, various operations on data structures, what is algorithm and complexity of algorithms. Let's see what is meaning of data types. A data type can be defined as set of values and set of operations which are permissible on those values. For example, an integer data type in C language can have range of values from -32,768 to 32,767, and we can perform set of operations on them like addition, subtraction, multiplication, division, etc. Suppose we give int data type to values 10 and 90 in Java, so we can perform operation like addition on them. Data types can be classified into two broad categories. First is primitive data types and second is abstract data types. Primitive data types are also known as predefined or basic data types. These data types may be different for different languages. For example, in C language, for storing the integer values, we use int short, and for storing real values, we use float, double, long. Next data type is abstract data type. The term abstract stands for considering apart from detailed specification or implementation. Abstract refers to the act of representing the essential features without including the details. Means we only know what method is performing, but we don't know how it is performing. Data types provide set of operations that are permissible on those values. Abstract data types uses the following two principles. First is encapsulation. It means providing the data and operations on data in a single unit. Example is stack, queue and tree. Second principle is abstraction. Abstraction means hiding the details of the implementation. Example is an abstract class. Abstract class in Java exhibits means shows what it does through its methods, but the details like how that method works is hidden from the user. Next topic is operations on data structures. The data stored in various data structures can be processed using various operations. The choice of a particular data structure for a given application mainly depends upon the frequency with which such operations are performed. Means we first understand that whether operations which are provided by data type fulfills the need of applications or not, and if yes, then only we can use that data type in our application. Some most frequently used operations known as primitive operations. They are low-level operations which are independent of programming languages. Example is assignment, arithmetic and logical operations means addition, subtraction, comparison, etc. Let's see some other operations which are applied using primitive operations. First is insertion. Adding a new element into data structure is known as insertion. For example, when we add a new element in data structure like array, then that operation of adding element in an array is called insertion. Second operation is deletion. Removing an element from the data structure is known as deletion. So when we delete an element from an array or linked list, then the name of that specific operation is known as deletion. Third operation is traversing. Accessing each element exactly once in order to process it is known as traversing. Fourth operation is searching. Searching means finding the position of a desired element in the data structure. Besides these basic operations, there are some other operations which are less frequently performed on some data structures. First operation is merging. Merging means combining two or more lists into single list. Second operation is splitting. Splitting means dividing a single list into two or more lists. Third operation is copying. Copying means creating a duplicate copy of a list. Fourth operation is sorting. Sorting means arranging the elements in ascending or descending order. Next topic is algorithm. An algorithm can be defined as finite collection of well-defined steps designed to solve a particular problem. An algorithm must have the following characteristics. First characteristic is input. So an algorithm must take some inputs that are required for the solution of a problem. Second is process. An process must perform certain operations on the input data which are necessary for the solution of a problem. Third is output. An algorithm should produce certain output after processing the inputs. Fourth is finiteness. An algorithm must terminate after executing certain finite number of steps. And last characteristic is effectiveness. Every step of an algorithm should play a role in the solution to the problem. Also, each step must be unambiguous, feasible, and definite. So, when algorithm achieve all the given characteristics, it will give the best solution of a given problem. This diagram shows that many algorithms or solutions can be derived for a given problem. So we need to find out which algorithm is best, or in other words, which algorithm can give best result. For this, we need to analyze an algorithm and find out efficiency of each algorithm. Efficiency of an algorithm can be calculated in two metrics. Those are time and space. First is space complexity. Space complexity of an algorithm represents the amount of memory space required by the algorithm in its life cycle. The space required by the algorithm is equal to the sum of the following 2 points. A fixed part is a space required to store certain data and variables that are independent of size of the problem. For example, simple variables and constants used in program size, etc. A variable part is a space required by variables whose size depends on the size of the problem. For example, dynamic memory allocation, recursion stack space, etc. Space complexity is sum of fixed part and variable part. Second type of complexity is time complexity. Time complexity of an algorithm represents the amount of required time by the algorithm to run to completion. Time complexity depends on input size. In other words, we can say that time grows linearly as input size increases. In this video, we studied concept of data types, operations on data structures, what is algorithm and complexity of algorithm. So that's all for today. Thank you for watching the video. Let's meet with another interesting topic in upcoming videos. Till then, keep learning.